Hello. And are we living in a multi-dimensional world? And if so, are we multi-dimensional beings? Um, I've never done a video on this before, and I've really never studied multi-dimensional beings, and I've really never heard of multi-dimensional waves until I went to take a picture of the sun tonight. And I thought, why does that sun look wavy? Okay, why does it look wavy? And why does it appear as if there are three poles? Okay, really three poles, and like maybe three outlines of a sun. 1, 2, 3. Why? I would think that if I moved the camera, I would have one great big streak. I wouldn't have three individual poles, telephone poles. So then I looked up multi-dimensional waves because I've got a wave here, you all, I do. And I found something on multi-dimensional waves. They exist. And I want to thank you all for coming on here. Hello, everyone. Yes, hello. Let's come over here to this live stream. I want to do this, and I want to do the live chat just like that. Hello there, Queen Karma 44. Hello, everyone. Thank you for coming in here. Yeah, so y'all, let me put this back to me. So that's what I did. I went outside with my Nikon camera. I thought that sun looks really bright, and it did look really bright. And this is really what the image right here. This was like my first image right here. You can see the timestamp. Actually, the sun was really big and bright white. And I thought I'm going to go up the road, and I'm going to see if I can get a picture because the trees hide the sun. And here's the pose. 1, 2, 3, 4, and then here's one here. But then if you look over here, like there's three poles to this one pole. 1, 2, 3. And it's the same thing with the other poles. There's three, and there's three suns. 1, 2, 3. And we've got these waves. But yet the waves aren't up here. They're kind of stuck like down in here. And I'm thinking, kind of like plasma or something. Only one time before, when I was taking a picture of the moon, did I see some type of an effect like this, as if the moon was dripping plasma. But this wave right here, you all, this wave, it's a real wave. And if you're just tuning in, I've never spoke on this before, never heard of it before. I've heard of multi-dimensions, but never a multi-dimensional wave. I haven't. This is like the original photo before I took this second photo right here, you all. Just like that. Let me come down here. So look at this wave right here. This is a multi-dimensional wave, and that's really, it's like do they call this somewhat like a double helix or something like that? I don't know. It just twirls around. You see all the twirling around, and yet these twirled, but these stayed straight. They stayed straight. And this sun is like 1, 2, 3 for that sun. If you're just tuning in, let's go look into this. Let's come over here to where I saw the multi-dimensional, well, here's three worlds, multi-dimensional world. And there is talk that we live in this type of a world. We've switched timelines. I've heard that we have. I have. You know, what I find really interesting is this Dragon Ball Z too, how Dragon Ball Z came into the picture also. Okay, I found out. See, look at this wavelength. So, Sela Theory 23, the new discovery of multi-dimensional. And I'll let you look at this right here. Here's some optoelectronic advances, multi-dimensional wave field signal study. like this multi-dimensional manipulation of wave fields based. Okay, so look at this one. An autoresonant three-wave interaction. So that would seem like multi-dimensional. What's this? This looks kind of like a NASA product. It really kind of does. Waves, versatile rogue waves in scalar, vector, and, well, you talk about scalar, vector, and what? Should I click into that? I did. Clicked right into it, UL 2017, Journal of Physics and a Mathematical and Theoretical Planes. Yeah, that makes sense. It's dedicated to recent progress in the active field of rogue waves with an emphasis on the analytical prediction of versatile rogue wave structures in scalar, vector, and multidimensional integrable nonlinear systems. A brief outline of the historical background of the rogue wave research. I didn't know they called it a rogue wave research, but that's what they called it. It's a rogue wave. I'm talking about peregrine solitons and the baseline modulation instability as an origin of rogue waves and the relation between the integrable turbulence and rogue waves. Okay, illuminating. So that's about all that you see in it. They got this stuff like that. Is what they've got. So no, I'm not doing that, I'm not going to go there. I wanted to get to the one that I took a picture of, if I can find it. Where are you at? Right here? Look at this theory right here. And I'm talking about that because when I took a picture of the sun tonight, it was so big and white. I put on 1000 ND filter on the end of my Nikon camera because I thought I want to get a clear image of the sun, not one the great big old light bulb. Okay, and that's what I did. But then this came in, this like wavelength that you see next to it. Hello. So let's look at this. I've never heard of this theory. That's about right. I am not lost. I am not lost. The page you're looking for, that there are so many of these things appearing on the internet. You know why? They don't want people to find them. There's so many of these right here. Why they had to call it a 404? Why can't you call it a 411? Why you had to do a 404? Okay, why? So they didn't want us to look into that, The Sela theory, that's okay, because you know what I can do? I'm going to copy it, and I'm just going to look for it myself. I don't have to have that particular. Somebody's going to come around. Let me see this. Do we need a moderator on here? Because I'm going to have a volunteer one. Is what I'm going to have to do if we need a moderator, because they don't get they don't get notified until maybe 20 minutes afterward or something like that. Yeah, but that's okay, you all. That's all right. Yeah, that's right. Does anybody want to be a moderator? Because I can just push that button and you can be a temporary moderator for this live stream if you wanted. Yeah. So look at this, you all. New discoveries. Oh, what are neutrinos, photons? About that. Yeah. Oh, if I see somebody on here, I'll just block them. I will. I ain't got time to play because it's distracting. So the Sela theory, a revolution in light theory. Okay. Well, I didn't know that. Yes, Nanette, honey, you want to be a moderator? Or you say go on, please. Yeah, so we can go on, please. Look at this. The publication of 36 Sela Research Group abstracts by NASA Astrophysics Data System. Yeah. Okay, so we got this, you all. So look at this, you all. They're presenting a theory about the feasibility of existence of speed faster than light in several ways. Yeah. So we got 2 moderators on here right now, you all. That's great. Yes. So we got them. Yeah. So that is really interesting. The structure of an electron calculation. So, we got Einstein in here. The contradiction of equality of Einstein and Planck's formula for photons. Oh, wow, you all. So right here, it's kind of like twirling around with time. That's right, you're all twirling around with time. So yeah, that still does not answer my question as to why I have multi-dimensional waves showing up in my picture of the sun, because it looks like there's three suns, one, two, three, right here, and then you can see this is a multi-dimensional wave, and we have three of these straight up. How? See, that's what gets me. How could we have the wave and then have straight objects going straight up in the sky? Yeah. Oh, they better not hurt you, nature spirit, honey. That's right. They won't. If I'll go find you, if I don't see you on here, I can go find you in the whatever. Yeah. The aperture synoptic survey, it has something to do with dark matter. Aperture. Aperture synoptic. Aperture synoptic. Let me see that. Aperture synoptic survey. Let's see. Where do we come? Hello, everybody. Thank you for coming in here if you're just joining in. Well, oh, we got the Large Aperture Synoptic Survey telescope. Well, isn't that? Let's take an image of it, you all. We can get it. Whoa, that is massive. Wow. That is enormous, you all. That's in Hawaii. Is that one of the ones that are in Hawaii? Yeah, I can't go everywhere at one instant. Look at that. The Large Synoptic Survey Telescope. Yeah. I'm not going to go on that subject, Tina Marie Cobble Patterson Mann. No, I can't get on that subject. I'm looking at this big, gigantic telescope. It's studying space. Wow. Hello there, Apple Brooks, honey. Thank you for coming on here. Yeah. Okay, so we got this. We're going. That's right, you also look at this. So look at this one. The wide-seeing astrobites. What are they wanting to look at, you all? What are they wanting to look at? Well, that's not a multidimensional world, but this is the multidimensional world, like metaphysics, you all. Metaphysics. Turning a two-dimensional surface into three dimensions. Wow, you see the wave of it? The wave of it is just like the wave of this in my picture. It's wave 2, so I guess that would be one of the ways to... But what's it showing up right here in the middle for is what I want to know. Why is it... there was a gap between me and this, and then obviously that's one sun, two sun, three sun, and 1, 2, 3. And it was only one pole. Just one pole is all it was. Where did I have that picture at? Right here. This is the original right here. This is what the original looked like. One of the originals. It took that one pole and it turned it into 3, and it took this one sun right here and it turned it into three curves. 1, 2, 3, and I guess they took their own shape. Hello there, Starfire. So then we've got this right here. 1, 2, 3, and then 1, 2, 3. It duplicated it, and then you've got that multi-dimensional wave. You know, have you ever thought yourself, what if you ever ran into... Do you ever ask yourself, what if I ever ran into my double? Okay, they say there's a double to everybody on the earth. They do. And have you ever been told that you've been somewhere and somebody said, weren't you just over there? I saw you over there and I just got through talking to you over there. Have you been mistaken for someone else by a different name, but they swear up and down it was you? Has that happened to you? Is what I'm wondering. Hello there, Starflower. Doppelgangers. Yeah, you have to ask yourself, where do the gangers come from? Where do they come from? Could they be you in the exact same world? Could they be? I did work with a teacher in Maryland when I was a teacher assistant. She was a teacher, I think, in the she was a second grade teacher. She was older than me. I think she might have been maybe 10, 15 years older than me, but you know what she looked like? She looked like me. I had long hair at that time, but she looked like me with short hair, but much, much older. And I would stare and I think, wow, if my hair were short and if I were older, would I look like her, exactly like her? Because she was the same height, same body build, all of it, every single bit of it. So it really does make me wonder at times, like you say, with the doppelgangers, what's going on? Really, what's going on? Johanna Maynard, it could be a glitch. Just like this picture right here of the sun. It looks like something happened right there. Something did happen, because really, that picture right here, it should have smeared every single bit of it. It should have been one great big smear and not individual, especially with this right here. Especially with this right here image. It should, if my camera was shaking, it should have smeared this. It should have been one great big smear, not one individual. See, it's perfect. Perfect. It's perfect. It didn't lose its structure, its atomic structure. It didn't lose it at all. And I guess this didn't either. This still kept it too. But then the waves, just like this, the waves, you all, I'm not an expert on this at all. I've never spoke about it in my life, you all, but this got me right here. How did that show up right there? In my picture, it's like a plasma. And is plasma part of the other dimension? Hello there, Al Sanchez. The CERN facilities, I'm sure CERN has a lot to do with it. A whole lot. Somebody mentioned something about a mystery boom in Bloomington, Indiana yesterday, like a meteorite. I'm not sure what it might have been. It's around I don't know, maybe 45 minutes away from me. North from where I'm at is what it is. So, multi-dimensional arrays. Okay, now see, this is what I noticed also, the Rubik's Cube. When I went to town with my husband today, I saw, oh, they got Rubik's Cubes out again. Rubik's Cubes out again. So look at how they're explaining this. 0, 1, 2 dimension planes. 0, 1, 2, 3 dimension planes. And then right here, 0, 1, 2, 3, 4 second dimension. So you got a first dimension, second dimension, and third dimension. Do you think the Rubik's Cube has something to do with dimensions? Could it? Could it really? I wonder if it could, you all. Does Rubik's Cube have something to do with dimensions? Yeah, obviously it does. Look at that. The Rubik's Cube approach, a multi-dimensional model. Oh, wow, for working with children. Well, I didn't know you would use the Rubik's Cube for working with children. That's strange. It really is strange to hear. The world's #1 brain teasing. I thought it had something else, you all, but there's bound to be, no, 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 no. We're not going to go there. We ain't going there, you all. We are not going there. I'm not going there. Okay, I'm not. I am not gonna go there, you all. I'm not gonna look into that Rubik's Cube because obviously there's something much more to that Rubik's Cube than meets the eye. Something much, much further to it. And obviously they have been using it for modeling purposes. A lot of different types. Yeah. So, I actually saw something about this right here. How they have the black and white checkered board. And actually, spirits through the black and white, they can summon spirits. They can summon the spirits up through there. I've heard about that. It acts like a portal. It does. It acts like a portal is what it does. Portal. Gateway to the multi-dimensional worlds. You know, I really don't want to go into another world. I do not want to summon any other dimensional entities. I do not want to do any of that, you all, at all. All I was wanting to look at is this discovery of the multi-dimensional wave. That's it. Just like that. The multi-dimensional wave. And you know, when you look at this, they this kind of reminds me of CERN stuff too. Multidimensional coherent spectroscopy reveals triplet state coherences in cesium lead halide perovskite nanocrystals. What? You got dimensions in these nanocrystals, you all? Have you heard about that? Look at this, you all. We're talking about dark matter. We're going to talk about dark matter. Experiments show efficient strategies evolve better over generations when people have a choice of a better teacher. Astrophysics set constraints on compact dark matter from the gravitational wave microlensing. Nanomaterials, light-dependent atom clusters for sensing applications. I wanna see this right here. This 11 hours ago, you all. April the 1st, the astrophysics set constraints on compact. You hear about those? Did you all hear about those? Really, those like black areas like that? It reminds me of the black cloud is what that's reminding me of. The effect called gravitational microlensing will change the shape of gravitational wave signals. And scientists can use such signatures to detect the pressure of black holes. Yeah, I think the problem was they didn't want to have all these teeny tiny. I'm having a hot flash on here. They didn't want to have any of these teeny tiny black holes popping up all over the place. And that was somebody's concern. When you started messing with the dark plasma, you're going to have all these minute black holes appearing. And you know, there was a movie once about black holes. They opened up something long years and years ago. They opened up a portal. This it kept growing and growing and growing. And you know, if you think about it, you ever seen the Never Ending Story where Sebastian had to give a name to somebody, but that place, it just slowly, everything just kept getting taken by the nothingness. Okay, the nothingness kept destroying the never-ending story. Everything was disappearing. It was more or less getting swallowed up by the nothing. And do you think that had to do with dark matter? You know, these like things, it's just like that. Let's look at this, you all. I'm supposed to be looking at this. The existence of dark matter remains one of the greatest mysteries of the universe. While studies have indirectly hinted at its existence, it is invisible in nature and makes this elusive substance very difficult to detect. Thus, its composition remains unknown. If its composition remains unknown, you should not mess with it. You really should not. Look at that. After lensed by a black hole. Dark matter could be made of fundamental and exotic particles that are yet to be discovered. Alternatively, it could consist of many massive and compact objects such as primordial black holes. Black holes formed in the early universe, and over the past decades, many teams of scientists worldwide have been searching for dark matter using a multitude of techniques, telescopes, detectors, observational data. While most of these searches were unsuccessful, they helped to guide and narrow down subsequent searches. Researchers at the Tata Institute of Fundamental Research in India, Tata, they had Tata people working in an area. They subcontracted out to Tata, and they were from India, and they had access to some very important data, big time data. And I thought, why are you hiring a foreign company to work here with access to all of this personal data? But they did. So look at that. They published a paper, and the Astrophysical Journal letters introduce a new way of probing the nature of dark matter by looking for microlensing effects in gravitational waves. Well, I don't know if my picture had anything like that, but it looks like a multi-dimensional wave. It really did look like a multi-dimensional wave, you all. So Einstein's theory of general relativity, massive objects bend light as normal optical lenses do. So massive objects such as black holes that lie in between the astronomical source and the observer, it can magnify the source. This phenomenon, called gravitational microlensing, has emerged to be a powerful tool for astronomers. Let's read that again. Massive objects, such as a black hole, that lie in between the astronomical source and the observer, can magnify the source. So if you have a massive object, if you had a black hole behind the sun up there in the sky, between the sun and you, and the sun is the source, can it magnify the sun and make it bigger? Can it? Would that be called gravitational microlensing? Am I reading that wrong? Massive objects such as a black hole that lie in between the astronomical source and the observer can magnify the source? That is an interesting statement right there, you are. A very interesting statement right there, because that sun is so bright. And it says, despite the extensive research efforts in the field, astronomers have so far been unable to observe the microlensing effect produced by black holes. This suggests that the black holes that are much lighter, listen to that, much lighter than the sun, which would produce the microlensing of light, are rare. Why did they have to use the sun as a subject? Is a black sun? Is a black sun possible? You know, they are talking. Sago Ori, she did something on the black sun. She did. And that's when I first saw her channel. It was really interesting what she had to say. And it was about the black sun. But yeah, so they sit there and talking about that. So you all, let's look at this. Let's read this again. This is important. Massive objects such as a black hole that lie in between the astronomical source and the observer can magnify the source. This phenomena is called gravitational microlensing, and it has emerged to be a powerful tool for astronomers. Despite the extensive research efforts in the field, astronomers have so far been unable to observe the microlensing effect produced by black holes. So this suggests that black holes that are much lighter than the sun, which would produce the microlensing of light, are rare. Now they're throwing in a hypothesis. Even if, okay, they're saying they know they exist, so that's why no. They know that these black holes exist, or they would not have taken the time to write this paper. They would not have taken the time. Okay, so even if these black holes exist, they are likely to constitute only a small fraction of the dark matter. That's just this one individual. Theory predicts that gravitational waves will also be lensed in the same way. If primordial black holes that are much more massive than the sun are abundant in the universe, they will distort the gravitational waves. Do you think, what if, I do have waves in this picture right here that I took tonight. And what if all those times, but probably not the majority of the times, that we're looking up in the sky and there are big gigantic waves. And what if they're not all due to HAARP? What if they're not? What if it's something else? What if it is? This sounds pretty interesting. It really does. So let's shrink this down. The upper limits on the fraction of dark matter in the form of compact objects obtained by this study. In 2003, some theoretical physicists accurately calculated the nature of gravitational wave distortions. Almost 2 decades later, Song-Hoon Jung and Chang Sub-Hsien, two scientists at Seoul National University and IBS Theoretical Physics, suggested that the non-observation of these distortions by LIGO and Virgo collaborations could help to constrain the abundance of black holes that are significantly more massive than the sun. More massive than the sun. You got the plasma in the petroglyphs. 2018 LIGO Virgo collaboration searched for signatures such as distortions in the gravitational wave signals. You know that I think they've got products like that at the iswa.gsfc.nasa.gov. I think they've got products where they too are watching. I really think they do. So they've only observed 10 gravitational wave signals, and I don't think they're going to find, no, it's not low, it's very high. In fact, they probably already found them, you all. Look, they have analyzed more than 50 gravitational wave events, micro-lensing distortions in any signals they were unable to observe. No. Look, they constrained the fraction of dark matter that consists of the black holes. No, I think there probably is these black holes. Look at this. Mysterious clouds. Let's look at that, you all. We're supposed to be talking about multi-dimensional worlds, and how am I going to get on this black plasma, these dark holes, this dark matter, you all. We got dark matter right here. The hunt for gravitational waves, ripples in space and time caused by major cosmic cataclysm, could help the universe's other burning mystery, the boson clouds, and whether they are leading contender for dark matter. They want that dark matter. They want it. They want to detect gravitational waves up to billions of light years away to locate the potential boson clouds made up of ultralight subatomic particles that are almost impossible to detect, and a source of dark matter, which is 85% of the universe. They're supposed to be gravitational waves caused by boson clouds circling black holes. Ultra light. I want to say ultra. Didn't they say something today? I read something today about some kind of electric, I don't know, thing coming to the earth. Not just plasma, but something else from the one of these belts, like photon belts or some kind of Van Halen belt or something like that around the earth, coming to earth. See, this is weird. See, look at this. See, this got the wave. This looks like a multi-dimensional thing. Look at it waving up like that, you all. They want to examine the energy of rapidly rotating black holes right there. Look at that. We believe these black holes trap a huge number of particles in their powerful gravity field, and it will open doors that were previously locked to scientists. Black holes, neutron stars will allow us to look for new particles and dark matter. They want the dark matter. If they got the dark matter, then they think they're gonna have all the answers to how the universe was formed. Look at this. A boson cloud younger than 1,000 years is not likely to exist anywhere in our galaxy, but clouds that are made up of 10 million years old are not likely to exist within about 3,260 light years from Earth. How far is Nibiru? How far is the Nibiru, they say? How long does it take to, make its way around Earth? Did they use that number 3,260 with Nibiru? Hello, everyone. The Van Allen belt, yeah. See, I took my phone down from here. I got to put it back up here because I got myself. This thing keeps going back to something different. Nibiru. Let me put this here, you all. Nibiru, let me see if I can do this, you all. I'm sorry, I jumped off on this rotation. Let's see how many it says. The 12th planet. No, they say 3,600 years. I thought I read somewhere that it did say something like, where am I at on here, you all? Something like 3,000. Let me see this. 3,260 years. I'm going to type that on there anyhow. Let me just type that number in there. I just want to do it. Just to do it. No, they got 3,600. No, I can't find it. I was trying to trick it, you all. A small rig ray-toting NATO left side handle 3260 B&H photo. We found a 3260 B&H photo video, you all. That's what we found with that number. That's pretty funny. It really is funny. That's all right, you all. Let me put this back to me. But when they're talking about primordial black holes, also 10-4. Yeah. So they were talking about primordial stuff, you all. Primordial stuff. Let me put this back to me for a second. Um, I that word primordial. I actually wrote something. Oh, it's been quite a while. It's been quite a while, but I wrote something and I had used the word primordial. Primordial. Oopsie. Yeah. Let me. Oh, I wrote this on January the 20th of 2022. I wrote this. Um, I wrote something. Let me see if I can see myself on here. I thought, where did I write the word primordial? And it's let me see if you all can see this. So right here in my cell phone, I had wrote the word primordial. Can you see it? Okay, so I did write it, and it was in January. I'm going to read that, you all. This is weird because I wrote this down. My ear is burning. So this was January the 20th of 2022 at 4:29 p.m. Somewhere in the past, our future was written and our past was forgotten. Before the concept of time, before the concept of man, there was the I am, the primordial force that governed all that is, all that was, and that all that is to come. The fundamental beginning of man was just that, a fundamental beginning. Fast forward with the event of time and space. Here we are today, facing the future that was written about in the past, written by those who sought and seek to subvert the destiny of mankind, those who, through powers not of this world, but powers, I keep hitting the wrong button, but powers beyond this existence, shall fail. May the peace that passes all understanding fill your heart this day. Love you. So I wrote that. I thought primordial force. Wait a minute, I used that word before in a writing. That's right, you all. That's what I did. Yeah, y'all. I gotta put this phone back on here, you all. I jump all over the place, but that's okay. Sometimes I really do jump all over the place, but it's all right. Let me see if I can get it, you all. Talking about, are we multidimensional beings? And I think we are bound to be some type of multidimensional beings. Let me get back to my subject right here. And they got the Rubik's Cube. Okay, they do. See, look at this. 3 ladies depicted in 2 dimensions. What is... By Chipka Photography. Why would she depict 3 ladies in 2 dimensions? 3-dimensional studio art. 3-dimensional studio art. The world map, shaded relief, 3-dimensional rendering. Well, they say that we live in a 3D world, right? They do. They say we live in a 3D world. They say that perhaps when you look in the mirror, that person that you're looking at in the mirror actually exists in another dimension, like it's another aspect of you, but it's in its own dimension. And even like your shadow, what if your shadow's it's another dimension, yet it's in this dimension too? What if it is, like Peter Pan, how he lost his shadow, and Tinkerbell had to catch his shadow and sew it back to the bottom of his feet because his shadow got away from him. So what if there really is something to that? Really, what if there is something to that right there? Yeah. Let's look at this. What we got going on? Yes, you all. So let's talk about that. So really, I wanted that one subject right here. This really is this one right here, talking about this black hole, the particles, if they exist, right here. international study, The Hunt for Gravitational Waves Caused by Black Holes. If you're just tuning in, somehow I ended up on this. What happened to that? I'm trying to look at the... I thought we read something about the word source, and I thought it was in here. Cataclysms, universes, other burning no, Gina, I think yeah, okay, here we go, right here. Right here, you all. So, this was about the sun. This was about the sun and dark matter and the black holes, primordial black holes that are more massive than the sun. So, this is what got me. Massive objects such as black holes that lie. They're saying that this happens right here. Massive objects such as black holes that lie in between the astronomical source and the observer can magnify the source. Can magnify the source. So if there is a massive black hole or a black sun that is behind the sun itself, it can magnify the sun. That's what it sounds like it's saying. And they would call that a gravitational microlensing. It's a powerful tool. That's what that sounds like. Massive objects such as black holes that lie between the astronomical source can magnify the source. That sun that was so big tonight, it was extremely big. It was. So this suggests that black holes that are much lighter than the sun, which would produce the microlensing of light, are rare. Okay, so we can look up the black sun and the black sun microlensing sun. Let me type in that. Exoplanets, you all. Oh, look at this. Gravitational microlensing. The same method could hypothetically use our sun. What? Did you hear that? They could use our sun to find exoplanets by microlensing it, making it brighter. Is that what that sounded like? You all, both of my ears are red. This is a very touchy subject. That is what that sounded like to me. Whew. Oh my goodness. How did I end up right here? I wasn't right here. Did they stick me right there? I was not right there. I was right. Okay, yeah, I was. So, gravitational microlensing, the same method could hypothetically use our sun to see exoplanets. On March the 21st of 2022, the number of exoplanets passed 5,000, according to the NASA Exoplanet Archive. Lurking in our galaxy, approximately 6,000 light years from Earth, is a monster black hole. A monster black hole. Devoured by gravity. They know, now they know. They used our sun. You know, there is no hypothetically using of the sun. Let me just say this. They used the sun for gravitational microlensing in order to see this monster black hole. That's what they did. They used the sun and made it super, super bright. So just suppose that now that's why the sun's so bright. And then maybe perhaps that's why there's so many chemtrails and stuff in the sky to help literally make this sky so bright and white that it really causes the sun's luminous to become even brighter so they can see even further into space. What if that? Okay, what if that? To see even further, like a big old magnifying glass. And what if that, you all? They could have done that. They could have done it. Yeah. This astrophysicist set constraints so on dark matter. This suggests that black holes are much lighter than the sun, which produce microlensing of light. You know they exist. So they've got a monster black hole. So I need to change this. Lurking in our galaxy 6,000 light years from Earth is a monster black hole. A monster black hole. Do they want to bring that monster here? Yes. Hello, Tamara. Oh, I guess they do. Devoured by gravity. Oh no. Look. Cygnus! Do you know what's important about Cygnus? They're looking for that star. It's in that constellation. They are. You remember that? That Jewish rabbi Berger is looking for that KIC 93227 in the constellation of Cygnus. That's what he's looking for, and Cygnus X1 presents it's dinner time and you're the meal. Lurking in our galaxy approximately 6,000 light years from Earth is a monster named Cygnus X1. This black hole, which is 14... Wait a minute. 14.8 times the mass of our sun. We just saw this number. Well, no, they was talking about Greenland being, or the Africa being 14 times. Okay. 14.8 times the mass of our sun will stretch and squeeze anything it captures in its immense gravity. Cygnus X1 is waiting snacky. Why do they have to write this like a monster? Okay, that's what they did. They wrote it as if it is an enormous monster that's going to devour us. That's what it sounds like. Feed us to the black hole, that monster. That's what it sounds like. That's how they're writing it. As if it's but it's not fictitious. It's not. Yeah. Oh my gosh. This is too wowed, you all. Now we got into much more than the multi-dimensional. They got a disk. The thin disk is 2,000 light years thick in our part of the galaxy. Who's got a thin disk? Somebody's got a thin disk. The best timeline yet for the Milky Way's big events. Oh, our galaxy formed its original disk 2 billion years before its stellar halo. I didn't know we had a disk. Well, I guess I might have. The Milky Way arches over the large sky area. Multi-object fiber spectroscopic telescope in China because it's the biggest spectroscopic telescope in the world, since the one that we had in North America or whatever, somehow it collapsed and it was no longer operational. And China just so happened to have one like it. So now it is the biggest one in the world. Yeah, you are. Oh, wow. The Bernstein Bear dimension. Yeah, you are. So let's look at this. So Imagine you discovered a barred spiral galaxy that was a Milky Way twin. Oh, now they got a Milky Way twin. Okay, look at this, you all. They're talking about this multi-dimension. So imagine you discovered a barred spiral galaxy that was a Milky Way twin because of the size of the bulge and disk, the arrangement of the spiral arms, and other characteristics just like those in our galaxy. So if they're telling you to imagine that you discovered a barred spiral galaxy that was a Milky Way twin, they're telling you they found it, just like ours. Look, astronomers identify the missing link, a mid-sized black hole. The new identified black hole is more than 50,000 times the mass of our sun, and it sits about 740 million light years from Earth in a galaxy containing fewer stars. Black hole, 1,000 light years away from Earth, 5.9 trillion miles. It's in our neighborhood. They said it's in our neighborhood. Why did they got this astro exam? A Milky Way twin. That's what they wanted. They wanted to find the Milky Way twin. But this right here, they got this monster, you all. If you're just turning in, they got this monster that's lurking in our galaxy approximately 6,000 light years away from Earth. And it's Cygnus X1. And don't get too close or you're going to become its next meal. That's what they're going to become, its next meal. And you're going to get devoured. Do you think they want us to get devoured? They could. They could want us to get devoured. And I'm serious. I am serious. Devoured by a massive black hole. Just like the never-ending story, and you just disappear into the nothingness until there's hardly nothing left. Yeah. Yes. So you all, this is wild. This is so wild. We got to talking about multidimensional waves, which you can see right here, the picture of the sun that I took tonight. Where am I at on here? I took this tonight of the sun, and this is what the sun looked like in one of my pictures right here, the photo of the sun. And you can see everything is in order. The sun's right there, the pole's right here, right here, right here. This probably is some kind of a ship. Okay, this is at 2001. And then I snapped one more picture. And then all of a sudden, I got this wave right here. I've got 3 suns right here. 1, 2, 3. And I've got 3 poles in the place of the 1. 1, 2, 3. Because this is where the pole was right there. That 1 pole turned into 3 poles. Like 1, 2, 3. And the same with these 2. They all gained 3. They all had a number of 3. And that's what happened tonight when I took my picture. It kept its structure right there, and this got 3 too. This smaller one, 1, 2, 3. But look, they're even staggered like that. Isn't that strange? It's like 1, 2, 3. They go downward, just like this, and this is spiraling too. See, this has a spiral to it, just like that, like a coiling, and it looks like the looks like this right here, a multidimensional wave that took place right there in that picture. I snapped it, caught it at the right moment in time. I stood in the very exact space is where I stood, boom, and caught it. So I think we probably do live in a multidimensional world because we got these multidimensional waves. And at any moment in time, I guess it can make an appearance if it wants. I think it's possible. I think it's very possible because it did happen, you all. It did. So, yeah. Oh my goodness. Yeah, there's so many universes, but this thing right here got me. So the Cygnus S1, X1, devoured. You're going to be its next meal. Don't get too close. You're going to be its next meal. You know what I'm going to do? I'm going to look that up too. I am going to do this. Um, I'm just going to say Jewish or Hebrew. I'm just going to see if I could see anything on it, you all. I really wanted to see if I could. The drop zone. Westerly's topic in speakers. Dark body. Pierre Simon, Einstein theory. Oh well. That's okay, you all. I can't really find much in it. I can't. No, you all, this is, I'm not going there. I'm not going there at all, you all. In fact, I am not. I'm not going to go there at all, you all. I'm done looking. I'm done looking. And I'm gonna end this video, you all, because you never know what you're gonna find on this internet, and they literally will. They'll stick inappropriate stuff on there just to get you in trouble. Okay, that's like a warning. Stop what you're doing right now. We're gonna send some more stuff your way. That's right. Yeah. Oh my gosh, you all. So I think we do live in a multi-dimensional world, and there's doppelgangers, and I'm sure there's lots of other things that you've noticed. I came home from work one day, I think it was a couple years ago, and I could have swore my husband was driving his Jeep right past me. And I thought, what's he doing home? He should be at work. And then I got home, and his car was already in the driveway. This car that I passed, it looked like my husband in the Jeep, and he was going totally the opposite direction. But then when I got home, there was his vehicle right there in the driveway, and he was at home. He didn't go nowhere. So that was really strange. It really was strange. Yeah. That's right, you all. So I am going to go, you all. I think I've said enough on something I didn't really know much about. I didn't. I still don't. I just have a tad bit of information about it. Yeah, I am doing great, you all. I am, but I am going to end this video. It's like 10 o'clock at night, and yeah, that's interesting. The most interesting thing tonight is this right here. This is the most interesting thing. Massive objects such as black holes that lie in between the astronomical source and the observer can magnify the source. It's gravitational microlensing, and it's a powerful tool for astronomers. And the other thing that's really, I think, the most important is this suggests that black holes that are much lighter than the sun, which would produce the microlensing of light, are rare. So it could be, that sun is so big, and it could be that there is like a black hole or a black sun behind it, and it is magnifying the sun, which would be the source. So I think that's pretty interesting. And it could be another theory as to why that sun looks so massive, and why the sky is white a lot, and why it's so bright it hurts your eyes, because maybe they're magnifying it, using it to look deeper into space, because they found that Cygnus X.1 massive black hole monster lurking, and it could devour us. Okay, so they can look further. Who knows? But I want to thank you all for coming on here. Thank you, moderators. And hello there, O-Rider. We believe that you have been working your butt off. That's right. You've been working. You're a hard worker, and there's nothing wrong with working hard. All hard work brings forth a profit, but mere talk only results in poverty. Okay? Yeah, you can say you're going to do something all this time, all the time, but if you don't put those words into action, it ain't going to happen. It'll just be empty words that never come to fruition. Yeah, that's okay. You can work hard. There's nothing wrong with it. There's a lot of people on here that work hard too. We appreciate a very hard worker. Yes, we do. That's right. Oh, my goodness gracious, you all. That's okay. Oh, you're welcome, Tamara. My hair looks great. Guess what? I don't fix it in the morning either. I don't. I might have had to wet it down a part this morning because it was sticking up. But yeah, I don't really have to do anything with it. I like my hair this short because I can just let it go. Okay, I can. And you're welcome, Moonstar. It's good to see you all on here. It is. Hello, Jay Jocelyn, Lorianne. 3 a.m., Lorianne. Aw, you stayed up. I hope you get a good sleep. I really do. That's great, Alexa. And I know you're not the Alexa that is on the phone when we call on the phone. I know you're not that Alexa. The dark crystal glows. The three suns. That's right. Michael Phillips, the dark crystal and the three suns. Happen every thousands of years. That's right. Oh, you're welcome. Yeah. Okay, I'm gonna go, you all. I don't want to, but this has been a really, probably it's been a long video. I don't know how long I've been on here. 1 minute 7 seconds. Oh, you're so welcome. I never know what I'm going to share. 90% of the time, I really don't. I just go with it. And really, at times, you're not supposed to think of what you're supposed to do at times. I like to let it come natural. I really do. Yeah, I'm going to quit that. I'm going to quit it, you all. I'm going to quit pouncing on my phone, my microphone. I'm going to go, you all. So thank you all so very much. And intuition, that's right. Johanna, thank you for stepping in, being a moderator. You're so very welcome. Yeah, and thank you all. Thank you, moderators, for everything. And thank you all for sharing all your comments. I think it's really interesting about the microlensing, gravitational microlensing, which literally magnifies. It's a magnification technique used by astronomers to look further out. And that's how they found that massive, giant black hole lurking. And if we get too close, it's going to eat us up, is what it said. And it's called Cygnus X.1. Yeah, that's what it's called. So with that being said, I am going, you all. So hello, wherever you are in any part of the world. Hello from my heart to yours. Love you. Have a wonderful rest of your day, and thank you so much. And I look forward to being on here again. Love you.